So it is another video. Numerical part on the properties of air. Okay, numerical on the properties of air. You know that air is also the mixture of so many gases. Most of all you must be aware of that. That is nitrogen first, that is around 78-79%. Then oxygen, that is around 21 to 22%. And after that argon 1%, and all other gas are in very small amount. Hydrogen, CO2, CO, so many gases are there. So numerical properties of air. But the major part of the air on which we are going to solve the numerical is air, dry air and water vapor. Everywhere air contains dry air and water vapor. Air is mixture of dry air and water vapor. This water vapor remains in the form of superheated portion. That's why it is not visible. This water vapor remains in form of superheated portion. That's why it is not visible. Next, and this air, 100 kilopascal pressure of the air, that is 90% is around your dry air and 10% is around your water vapor. Okay, and this water vapor remains in the form of superheated vapor. Now we are going to solve the numerical. A mixture of dry air and water vapor is at temperature of 21 degrees centigrade. That means dBT, dry bulb temperature. Under a total pressure of 736 mm of water, the dPT, dew point temperature, is 15 degrees centigrade. So three things are given: dBT is given, dPT is given, and pressure is given 736 mm of mercury. So we have to find out so many things. Firstly, we have to find out partial pressure of water vapor. Secondly, RH, relative humidity. Thirdly, specific humidity. Fourth, specific enthalpy of the water vapor by three methods of the given figure. One figure is given between temperature and entropy, and you see at this partial pressure, if the temperature is reduced, it comes to the G, it comes to the point G, and at this G the temperature is TD, that is dry bulb temperature. And now if the water vapor is sprayed, then it comes over here, temperature goes to 0 degree centigrade, and this 0 degree temperature is here. A and B and C are the common point on the same line, and there the temperature has been taken as T. So we have got this TS diagram. Now solution number one part, we have to find partial pressure of the water vapor. From the steam table, the partial pressure of water vapor at 15 degree dBT, at 15 degree dPT dew point temperature is PV is equal to 12.79 mm of mercury, and that comes out to be 12.79 into 133.5. We convert it into Newton meter square, so we multiply it by 133.5 meter, 133.5, and we get 1707.5 Newton meter square. Second one, saturation pressure of the water vapor at 21 degrees centigrade dVT, dry bulb temperature. That is PS, saturation pressure. It is given 18.65 mm of mercury. PS, saturation pressure 18.65 mm of mercury. So that 18.65 again converted into 133.5, that gives 2489.8 Newton meter square. So we have got the pressure, saturation pressure of the water vapor at 21 degree dVT and specific pressure, vapor pressure at certain temperature, that is 15 degree dVT, we get 17.07.5. In that case now PV is known and PS is known. Both are the things which are known. So we can write it phi is equal to RH, that is relative humidity, that is given by PV upon PS into 100. PV upon PS into 100. Multiply it by 100. So 12.79 divided by 18.65 into 100, that gives 68.58%. 68.58%. Now the third part, that is your specific humidity, that is given by omega is equal to 0.622 PV upon PA. PV upon PA. That can be written as atmospheric pressure minus vapor pressure at PV. Atmospheric pressure minus PV. That has been written over there. 0.622, 12.79 divided by 736 minus 12.79. Calculating all these things, we get the value of the specific humidity 0.011 kg water vapor, per kg of dry air. 0.011 kg water vapor per kg of dry air. Now, latent heat of vaporization of the water at dVT, dew point temperature, and dPT, dew point temperature and dVT, dry bulb temperature and dew point temperature, dry bulb temperature and dew point temperature. So latent heat of vaporization of the water vapor, that will be given by dVT and dPT. HFG at 21 degrees centigrade, that is equal to 2452 kg per kg of 2.5452 kg per kg, and HFG, that is 15 degrees centigrade, 2466.2 kg per kg. ठीक है, तो हमने at this dPT we have find out the latent heat at 21 degrees centigrade and another at 15 degrees centigrade. Okay, both has been find out. Now specific enthalpy of water. Now we have to find out the specific enthalpy of the water from the figure by three methods. In the question it is written over there, if you see, specific enthalpy of water vapor by three methods of the given figure. Figure was given over here between temperature and enthalpy and temperature and entropy. At 2 points it has been given, at PV and at saturation. So from the figure now, specific enthalpy of water vapor from figure by three methods, that is HC is equal to 4.1868 into 21 plus 2452, that is equal to 2540 kilojoule per kg of water vapor. Okay. Similarly, HA, you can see from the figure also, SC is given over here and HA is given over here. HA, that is given by 4.1868 into 15 plus 2466.2, that plus 1.88, and temperature difference 21 minus 15, that gives 2540.3 kilojoule per kg of water vapor. Kilojoule per kg of water vapor. So now HB, third one, 2501 plus 1.88 into 21, that gives 2540.5 kilojoule per kg of water vapor. The three values are very close to each other. Okay, you see the three values, 2540 kilojoule per kg of water vapor, again 2540.3 kilojoule per kg of water vapor, and 2540.5 kilojoule per kg of water vapor. All the three values are very close to each other. The three values are very close to each other. So we have to find out from the numerical specific enthalpies of the water vapor by three methods. Three methods means at the 3 points. So it has been found out at the 3 points, that is SC, HA and HB, and we see that all the values are approximately same. Next page. Now we are seeing that we have to find out next one, enthalpy of the air using the value of specific enthalpy of the water vapor from the empirical relation. That is enthalpy of air using the value of a specific enthalpy of water vapor from the empirical relation. That is H is equal to HA plus W into HV. This is the empirical relation available. H is equal to HA plus W into HV. Here 1.005 multiplied by 21, 1.005 multiplied by 21 plus 0.011 multiplied by 2540.5, that gives 49.0 kilojoule per kg of dry air. Okay, 49.0 kg per kg of dry air. Now the next part, that is your specific volume of the air is equal to the volume of the 1 kg of dry air or 0.011 kg of water vapor based on the dry air. So we get V is equal to VA is equal to RA into T divided by PA. वैल्यू रखते हैं हम, RA की वैल्यू स्टैंडर्ड है 287.3, it is well known value, multiplied by 273 plus 21 डिग्री को हमने केल्विन में चेंज किया, divided by PA, that is given by 723.21 multiplied by 133.5 to convert it into the Newton meter square. Calculating all these things, we get the value 0.875 meter square per kg of dry air. So we have to find out all the 6 things, that were the partial pressure of water vapor, then relative humidity, then specific humidity, then specific enthalpy of water vapor by 3 methods of the given figure. Given figure is there, TS diagram is there, this is your liquid line, this is your vapor line, this is your critical point, PV, vapor pressure of certain vapor pressure at certain pressure, vapor pressure of the water at certain pressure, it is being cooled down up to the G point, then from G, that is the transformation up to the liquid, then here F, it is completely liquid and the temperature is TD. Similarly, at point B, we are just impinging the water in the air, then the temperature goes down, it comes up to the point here G at 0 degree centigrade, again horizontal line, that is the conversion of the liquid into vapor form, then it is at 0 degree centigrade. Then We have got the third line also, a common line which has been drawn, A, B and C at temperature T. So there are three temperatures now, T, Td and 0 degree centigrade. Keeping that in view, we have to find out the specific enthalpy of water vapor by three methods of the given figure. So three methods of the given, I am going to repeat this one again because it is the important part. That is, we have to find out latent heat of vaporization of water at dVT, this latent heat of vaporization of water at dPT, dry bulb temperature, that is 21 degree centigrade, HFG. We can find out from the table, it can be obtained from the table, we can get it from the table, is equal to 2452 kilojoule per kg, Similarly, HFG 15 degree centigrade per, that is dPT, dew point temperature, that gives 2466.2 kilojoule per kg. Now, specific enthalpy of water vapor from figure by the three methods, HC, that is specific enthalpy at point C, is given by 4.1868 into 21 plus 24.52 is equal to 2540 kilojoule per kg of water vapor. Secondly, HA is equal to, that is at the point A, enthalpy 4.186 into 15 multiplied by 15 into 2466.2 plus 1.88 into 21 minus 15. 21 was your dBT, it was given in the question, and 15 was your dPT. So subtracting it, we get 2540.3 kilojoule per kg of water vapor. Then the third one at point B, again we have got 2501 plus 1.88 into 21, that gives 2540.5 kilojoule per kg of water vapor. So we are finding that all the three values are approximately equal to each another. All the three values you can see are approximately equal to each another. So we have find out this that was a specific enthalpy of the water vapor by three methods. These are the three methods which we have find out. Now the next page again, enthalpy of the air using the value of a specific enthalpy, and that was of the water vapor from the empirical formula, that H is equal to HA plus omega to HV, very standard equation. H is equal to HA, that is air total enthalpy is equal to the enthalpy of the air plus specific humidity into enthalpy of the water vapor. Okay, so we get 1.005 into 21 plus 0.011 into 2540.5 is equal to 49 kilojoule per kg divided per kg of dry air, okay. So in that way we have find out the enthalpy of the air using the value of specific enthalpy of the water. Next part is your specific value of the air is equal to the volume of the 1 kg of dry air or 0.011 kg of water vapor based on the dry air. So that part, V is equal to VA, that is given, is equal to RA into T divided by PA. RA is your 287 standard, 0.3 into 273 plus 21, that is again PA is equal to 723.21 into 133.5, that is equal to 0.875 meter cube per kg of dry air. So we have find out all the six values, a specific value of the air then enthalpy of the air, and then your partial pressure of the water vapor, RH, specific humidity, specific enthalpy of the water vapor by 3 methods of the given figure, and that was your enthalpy of air per kg of dry air and specific volume of the air per kg of dry air. All the values have been calculated. So thank you for the listening this video, and if you like it, please press the button. Okay, thank you.